So what really is the Pythagorean theorem and how does it work? Through this demonstrational video, we will be going over an example of how the Pythagorean theorem really works to further understanding of the Pythagorean theorem to further apply it into the world of mathematics. So the Pythagorean theorem allows us to find the hypotenuse of every single right-angled triangle of existence. Yes, you heard that right. No matter its shape or its size, this amazing theorem can help us solve any hypotenuse of any right-angled triangle. It is the relationship of the sides between the length of the sides of the right-angled triangle. So, as it is stated, the Pythagorean theorem is a squared plus b squared, which is equal to c squared, which means that the sum of the two smaller squares, a and b, is equal to the hypotenuse c. So what this really means is that in a right angle triangle, which can be indicated by a 90 degrees or a square marker, we will be able to find c, which is the hypotenuse, which can be indicated either as the longest side of the triangle or the opposite side of the square marker. So let's get our brains moving and start on an example to really get us to understand what the Pythagorean theorem is and how we can apply it. So drawing a right angle triangle with our A, B, and C points. For example, making A 4, B 5, and C remaining are unknown. This is what we have to look for. So applying the Pythagorean theorem onto this right angle triangle, we can say 4 squared, which is our A squared, plus 5 squared, which is our B squared, will equal to our C squared, which is our unknown. This is what we're looking for. So if we go on our calculator, 4 squared is equal to 16, 5 squared is equal to 25, and altogether, these two equal to 41. Now, this isn't where we stop. We still have a little bit more to go. So what we need to do is to get rid of this exponent 2. We need to isolate for the c to get the true value of our hypotenuse. So the way we can do that is that we square root our c squared value, leaving us with c. But what we do to one side, we have to do to the other. So we have to square root our 41, which equals to 6.40. Now we can see that our solution is 6.40 is equal to our c. So on our diagram here, we can say that our c value is 6.40. Now that we have the basic understanding of the fundamental foundations and applications of the concepts of the Pythagorean theorem, we can use the Pythagorean theorem to solve the hypotenuse of any right angle triangle that we encounter in mathematics.